They are the most destructive and costliest storms on the planet. Hi there, I'm Alex Wallace, and we're taking you inside the eye, exploring the deadly and dangerous power of hurricanes. Did you know the typical hurricane expends the force of 500 nuclear bombs during its life cycle? Relentless wind, devastating storm surge, and flooding rain, massive amounts of energy. Meteorologist Alex Wilson shows us this force of nature is unlike any other.
A tropical storm becomes a hurricane when sustained winds reach 74 miles per hour. They can be up to 600 miles across. Hurricanes are categorized on a scale of 1 to 5, 5 being the highest winds. Hurricanes rotate in a counterclockwise direction in the northern hemisphere and a clockwise direction in the southern hemisphere. The Galveston hurricane of 1900 is the deadliest, killing at least 8,000 people. And the costliest hurricane is Katrina in 2005, causing $108 billion in property damage. As for strongest, only 3 Category 5s have ever made landfall in the U.S. Hurricane Andrew in 1992, Camille in 1969, and the Labor Day hurricane of 1935. Hurricane season begins on June 1st and ends on November 30th. But hurricanes don't always follow the rules.
They can also seemingly defy the rules of physics when it comes to flying debris. Coming up, we'll show you just how much damage everyday objects around you can cause when they're picked up and thrown through the air at hurricane speeds. But first, to understand how these storms become so powerful, you have to understand how they're built. Here's hurricane expert Michael Lowry.
From outer space, hurricanes are a beautiful sight to behold. But let's take a closer look to see what's really going on inside these monstrous storms. That donut hole at the center of the clouds, that's called the eye, and it typically ranges from about 20 to 40 miles across. Here, conditions are actually pretty calm, with sinking, warming air, which keeps clouds and rain from forming. In stark contrast, though, right along the outer edge of the eye is a ring of thunderstorms called the eye wall. And it's here that you'll find the most intense winds, driven by dramatic changes in pressure, spiraling counterclockwise around the eye.
We are in the eye wall of Dennis.
And connecting to the eye wall are spiral rain bands that can extend for hundreds of miles from the storm's center. Oftentimes, it's these bands that are associated with heavy rain and have been known to produce tornadoes as they move ashore. So you see, there are actually many aspects of hurricanes, each with their own characteristics and threats. And that's what really makes hurricanes so fascinating.
You know what else is fascinating? Storm tracker Jim Cantori, in a wind tunnel, turned all the way up. But where do hurricanes come from? Well, that depends. Here's meteorologist Mike Bettis.
Did you ever wonder how hurricanes originate? Well, believe it or not, it happens way over near Africa, especially late in the season. We take you to the globe and show you how the Saharan Desert and the Atlantic Ocean interplay and actually can cause hurricanes. It's hot, it's dry at the Saharan Desert, right? We also have that cold ocean water, and right in between is a sweet spot for hurricane development because of the increasing winds from east to west. You get little spins that can happen in that zone, and next thing you know, tropical storms form and eventually hurricanes. If they travel all the way across the Atlantic, we have to be on guard here in the U.S.
When hurricanes get close to land, we can monitor their status with high-tech radar. But when they're still far out to sea, meteorologists need a way to gather life-saving information at long range. That's where the hurricane hunters come in. Storm tracker Jim Cantori explains.
One of the most important things that you need when you're forecasting how strong a hurricane is going to be and where it is going to go is data. We have satellites that give us data. We have computer models that give us forecasts. But what about a nice three-dimensional grid in and around the storm? You got to fly into these things. Let me introduce you to the 13 Hurricane Hunter aircraft fleet from the Air Force and NOAA. We're going to start you off with the first plane here. There are 2 of these. These are NOAA P-3 Orion aircraft. They can fly anywhere from 10,000 feet on down to 1,000 feet. They'll fly right through the hurricane. Interesting names, too, by the way. Miss Piggy and Kermit. Great sense of humor. You got to have one, right? You're flying through a hurricane. The first part of this plane is on the nose. It is called a gust probe. It looks like a barber pole, and it flies through and obviously measures the wind. So as you're coming in, you can see what the eye wall has. You can go through the eye with calm winds and then exit the other side and really get a nice look at what that wind is like through the storm at various levels from 1,000 feet up to 10,000 feet. On the belly, a radar. What do these storms look like, these towers, these rain bands in and around the storm as they're flying through it? This is what this horizontal radar does for us. On the tail, though, we want to look at a more vertical profile of those towers. How high are they? How rapid are they intensifying? Well, that's what the tail radar does here on the NOAA P3 Orion. All of the planes, all 13 of them, actually have this piece of equipment here. It is potentially the most important piece. It's called a dropson. And these dropsons, once they are launched out of the planes, give us data back every half a second. Temperature, dew point, winds, barometric pressure, giving us a nice three-dimensional grid of what the storm actually looks like ahead of and in the storm itself. The dropson. All right, who does the heavy lifting? The WC-130 aircraft. These are very, very important. We get data from these guys constantly, especially as a storm is approaching land. How deep is the pressure? What are the winds like? What are the atmospherics like around the storm itself? Very, very important. Now, of course, these guys got to know what they're flying into, right? So on the nose of the WC-130 is a radar. Right there on the nose. You know when you're going to go into the eye wall, you know when you're going to get into the eye, and you know when you're going to exit it as well. That's what that radar does. Inside the plane, several meteorologists working a mission lasting approximately about 12 hours. And again, guys, that's where we put the dropsons out. Very, very important role to give us an idea of what that storm is doing along the path. Now remember, they'll start out high and they'll work their way down toward the center of the storm and then exit out and rise once again. They saw it fly several missions in and out of that eye during that 12-hour time period. One of the most incredible pieces of equipment that's come along in the last several years on the wing of the plane is called the SFMR instrument. What does that do? Well, it looks at the turbidity of the wave action. What are the winds that it takes to produce those kind of waves? That's what that instrument estimates. And it gives us a great idea of what those winds actually are. A great instrument. That's the WC-130J. All right, one aircraft left. It's named Gonzo. It's the Gulfstream 4. This is responsible for high altitude data. Flies up to 40,000 feet. So now we've got a storm that's moving into an area, but we really don't have an idea of what's out ahead of that storm data-wise. So to give us a nice grid, the Gulfstream 4 flies INVEST missions essentially ahead of the storm to put that data into the models and eventually give us a better track forecast. These 13 aircraft are perhaps the most essential part of the arsenal we have in warning you about an oncoming hurricane.
Hurricane force winds, an icon of the weather world. Coming up, we'll show you what happens when debris goes airborne. And later, which American city is the most vulnerable to a hurricane? But first, time to test your hurricane knowledge. Do you know where the term hurricane comes from? It comes from the Carib Indians. Huracan was the god of what? And we'll answer that coming up. Before the break, we asked you about the Carib god Huracan. He was the Carib god of evil, and that's where the modern term hurricane was born.
I've got my crew holding me down, because otherwise we would probably blow away. There you go, producer and photographer holding us here.
Well, you know, I haven't seen a lot of debris recently, but it was a couple of hours ago that hold on. All right. Sorry about that. Wow, that was a heck of a gust.
Heading west down the Hurricane Highway. Did you ever notice that hurricanes tend to move across the Atlantic from east to west and then curve northward? Despite their ferocious appearance and size, hurricanes act more like leaves in a stream than a boat steering its own course. In the Atlantic, airflow is dominated by a large high-pressure system that hovers over Bermuda. Winds rotate clockwise around the center of this Bermuda high, and on the south side, the winds move westward, guiding hurricanes closer to our coasts. As storms approach the U.S., a hurricane either gets dragged northward around the Bermuda High or continues westward toward the Gulf of Mexico. This is a big reason why Florida, Texas, and North Carolina lead the nation in hurricane landfalls. So if you live in these areas, make sure you and your loved ones have a plan.
Do you know the difference between a hurricane, a cyclone, and a typhoon? Hurricane expert Michael Lowry explains it's all about location, location, location.
Hurricanes, typhoons, cyclones. But what's really the difference? In this case, actually not very much. They're all terms that we use to describe the very same weather phenomenon, a tropical cyclone with sustained winds of at least 74 miles per hour. They're also all low-pressure systems that draw energy from warm water to fuel organized thunderstorms, rotating around a central eye. And each year, on average, roughly 26 of these storms spin across the planet. Okay then, so what is the difference? Like real estate, it's all about location, location, location. Hurricane is a term that we use here in the Atlantic and the Pacific Oceans east of the international date line. But typhoon refers to a similar storm in the Pacific Ocean, but west of the date line and north of the equator. And the word cyclone, that describes any hurricane located south of the equator. Hurricanes and typhoons both spin counterclockwise, but cyclones in the southern hemisphere rotate the opposite direction. And no matter what you call it, hurricane, typhoon, or cyclone, you'll always want to stay out of its path.
No one is immune to the power of hurricane-force winds, and that includes television meteorologists. Check out this wild video of Stephanie Abrams battling Hurricane Francis and the flying debris in 2004.
We're seeing debris flying everywhere. Thankfully, my crew is looking out for me while I'm doing these live shots and trying to catch debris as it heads in our direction. We have seen windows blown out, power lines are down. Woo! And screen doors. Watch out, watch out, watch out, watch out! That's part of the roof that is headed towards us. I'm not sure if you guys can still hear me, but I had to get out of the shot so that we didn't get hit.
Just another average day at the office, right, Stephanie? Well, for more on the raw power of hurricane-force wind, here's senior hurricane specialist Brian Norcross.
Hurricane-force winds. They can mercilessly exploit every weakness in a building, and most of those standing along the hurricane coast are not built to withstand a Category 3, 4, or 5 storm.
But here in South Florida, people are trying to learn to do just that. And this super wind machine may be part of the solution.
It's called the Wall of Wind, a 12-fan research behemoth located on the campus of Florida International University in suburban Miami.
We can get up to Category 5 wind speed, incorporate rainfall, water, and bring it into a wind field that's larger than many other research facilities of its kind. That's incredibly important because there's lots of work to be done and research to be done when it comes to wind interacting with structures.
The wall is big enough and powerful enough that for the first time, full-size buildings, materials, and systems are being tested in real-world hurricane scenarios. The results have been eye-opening.
We find out that some materials that we think are very vulnerable, they perform very well, and some of the failures we see are never thought of.
On this day, metal roofs came under the intense power of the wall of wind. Seeing actual Cat 5 winds billow up or lift a small part of the roof tells designers that they have built a strong system.
What we're learning is that in a real wind event, that the billowing up of the panels is normal.
The Miami-Dade County Building Code has led the way for decades in prescribing how to make buildings strong. And now people are coming from all over the world to use this monster machine to learn how to make their communities strong as well.
Thank you, Brian. Coming up later in the show, we'll take you inside a testing laboratory where scientists launch debris at windows to test their strength. But first, more hurricane trivia. Do you know when the United States launched the world's first weather satellite? Here's a hint. It's the same year a famous American spy plane was shot down over the Soviet Union. The answer is coming next. Before the break, we asked if you knew when the United States launched the world's first weather satellite. The world's first weather satellite, TIROS-1, was launched on April 1st, 1960, and sent back thousands of images during its short lifespan of only 79 days.
The United States has been flying into hurricanes and tropical systems since the 1940s. And it all started with a dare during World War II. And now we've been routinely flying into these powerful storms every year, collecting invaluable information over the vast and data-sparse oceans. The current Hurricane Hunter fleet is made up of 13 planes, 10 Air Force, and 3 NOAA aircraft. Most of these missions fly directly into the eye of a hurricane and collect data at the lowest 10,000 feet of the atmosphere by dropping instrument packages that we call dropsondes. On the way down, these instruments measure things like temperature, humidity, pressure, and winds every half second until making their final splash into the ocean. Information is relayed back to the National Hurricane Center, where forecasters assess things like storm strength and organization. And thanks to these courageous data collectors, we know more about hurricanes than ever before. And in turn, forecast accuracy has really taken off.
We're just dealing with these sheets of rain and winds that are howling 50, 60 miles per hour. I'm going to ride this one out, guys. I'm going to ride this one out right here.
That was Jim Cantore riding out Hurricane Isaac in 2012. The highest wind speeds were recorded at 80 miles an hour during that storm, making it a Category 1. Meteorologist Mark Elliott has more on how hurricanes are categorized.
When it comes to hurricanes, each one's impacts are a little bit different, but the wind speeds that we talk about along the Saffir-Simpson scale, those are very specific, and the damage caused in those categories, kind of predictable. So let me show you. Let's start off with a Category 1 storm. And the damage here, not too bad. A couple of shingles fall off, you can have some palm fronds bending in the wind, but everything basically remains intact. Category 2, that's where you really start to feel it. Look at the windows of the house. They can be hit from debris from the outside and already start breaking in a Category 2. Your trees are significantly bent over in the wind, and the siding of the house itself can break, flapping there in the wind, adding to those eerie noises inside. Category 3. I've heard only a Category 3, but it's not only anything except really bad news. In a Category 3, you can have the door of the house blown in because the winds get so strong. You can have the roof of the house start to flap up and down in the wind because it can lift off those weak points, and a lot of those trees start to fall. Category 4, the damage is even worse. You get most trees falling, most of your windows breaking, most of your shingles fly away, and then Cat 5 is as high as the category scale goes. By Cat 5, no shingles remain anywhere nearby. The holes in the roof get so big that the walls of the house start to fall because they're not attached to anything anymore. There won't be any trees up in the neighborhood. That's just catastrophic damage.
Wind speeds get a lot of the attention when it comes to hurricanes, but they're not the deadliest part of a storm. As a matter of fact, hurricane expert Michael Lowry shows us the stats say it's not even close.
Look at this. This was a parking lot. So right now, as long as we're dealing with the eye wall and the surge, this water is going to stay up.
The surge from Hurricane Katrina put the Bay Waveland Yacht Club underwater and out of business for a while.
The water level up on that second floor there, with the waves just beating on it. And so what happens is the waves beating and beating and beating is what really takes down an event.
The most dangerous aspect of a hurricane sometimes isn't the wind, it's the water. Back in 2005, Hurricane Katrina brought an astonishing 27-foot storm surge to this part of the Mississippi Gulf Coast, the highest ever on a U.S. coastline. Now, our ability to accurately forecast these type of surge events is critical to warning the public, and that is where storm observation stations like this one can make a difference. There was a storm observation station with a surge sensor here during Katrina, but the power of the water destroyed it at the worst time possible for data collection, right at the peak of the storm. That won't happen with this new one.
What you're looking at is sort of the yellow pipe-looking device is essentially elevating the brains of the instrument up off the water so that it will survive.
Actually, more than 25 feet off the water, anchored by steel rods driven 70 feet down. And these sensors measure more than just the surge.
We have wind gauges, the air temperature. We have the water level tube right here that measures how high the water is, updated every 6 minutes.
Without knowing how strong the winds are and which direction they're coming from, you can't accurately forecast the surge. So wind measurements are critical. But there's much more involved than what category the storm is. In addition to the wind, other factors such as the size of the storm and landfall location play an important role. Hurricane Isaac in 2012 was a Category 1 that produced a storm surge of 8 to 10 feet here along the Mississippi coast.
Isaac created a much higher storm surge than you would normally see with a Category 1 hurricane, and the reason for that is the large size of the storm.
So, do we need a surge scale? No. The key is being able to tell people just how high it will get and if they should evacuate, which is why these stronger sensors are needed.
How about launching a high-speed projectile at a window? Come on, it's only for science and hurricane safety. We're back in the lab next. But first, can you name the deadliest hurricane of the 20th century? The answer is coming up. Before the break, we asked if you knew the deadliest Atlantic hurricane to strike during the 20th century. The answer happened on September 8, 1900 in Galveston, Texas. At least 8,000 lives were lost. They're the most destructive and costliest storms on the planet. Hi there, I'm Alex Wallace, and welcome back to Hurricanes Inside the Eye, an exploration into these deadly and dangerous storms.
And we are at the height of this storm right now as it continues to come in. We just decided to take a little walk around the side of the building, and you can see how the wind is accelerated big time here. We're easily gusting 70 miles an hour with this wind. I can hardly stand up.
Few on Earth have weathered more hurricanes than Weather Channel storm tracker Jim Cantori. His passion for extreme weather is unmatched. So who better to explain how these incredible displays of power look from the inside?
One of the most amazing concoctions that Mother Nature can stir up are hurricanes. These are huge heat engines that can expand hundreds of miles wide and unfortunately produce a tremendous amount of destruction. Their purpose is to take the heat from the tropics and distribute it poleward. Unfortunately, sometimes land masses get in the way. Well, with every engine, you need fuel. Water temperatures around 80 degrees. Let's bring this hurricane down and talk a little bit about it. As that warm, moist air rises, cools, condenses, towers develop, they get up there 20, 30, 40,000 feet. Then you have to evacuate that air in a process that we call outflow channels. So if you have low pressure at the surface, you need high pressure aloft to pretty much continue this harmonic process. And it's amazing, as big and as beastly as these things are, there are things that can disrupt the process. Cooler water, dry air in the surrounding atmosphere, and the biggest thing perhaps is wind shear. We know that strong wind shear can allow the system to tilt. Instead of having this nice vertical column that's going up in the middle in developing a hurricane, now you've got, check this out as we go under, a system where that updraft is now tilted off to the right, and the storm becomes sometimes decoupled. So you can even see on a satellite picture sometimes a surface circulation, a low cloud swirl, if you will, and all the thunderstorms juxtaposed off in the direction of the shear. So it's kind of an amazing process. In light wind shear, now you've got a system that can grow and intensify and even further expand in time. So let's take the clouds away and give you a nice slice of what this thing actually looks like, because as the storm is maturing, one of the things we look at on satellite and sometimes radar if it's close enough to the coast are features we call rain bands. These help to feed that warm, moist air into the center, creating, especially as the pressure's lower, the most powerful part of the hurricane. We call it the eye wall. It can be anywhere from 6 to even 30 miles wide and is the most destructive part of the hurricane. It has the strongest winds, and in the northern hemisphere on the right side of it, it has the highest storm surge typically, right near that eye. So with the eye wall comes the eye. As violent as that is, in the middle of all that, there's not even a breeze. Winds are zero, they're calm. And when you see Hurricane Hunter aircraft out there or get a nice satellite picture, sometimes you can see right through that eye. It's clear as a bell all the way down to the ocean surface, to a very turbulent ocean surface at that. So you know that the wind field surrounding these big hurricanes can produce a very, very turbulent and even rising ocean in spots. Nature's heat engines, the hurricane.
Wind versus water, a battle of the elements. But when it comes to hurricanes, one is distinctly more damaging to your home. Here's storm surge expert Michael Lowry.
When it comes to the devastation caused by hurricanes, many think powerful winds make the biggest impact. But the fact is, it's storm surge that's really most dangerous. Here, let me show you why. We've seen a hurricane winds turn even the most ordinary objects into deadly projectiles. And winds of 111 miles per hour can easily pick up and blow around parts of homes and other large objects, making it even more dangerous. Something as small as this can cause serious injury. But the force of storm surge moving at just 4 miles per hour is the equivalent of 111 mile per hour winds. And items carried by the surge can be even larger than the most powerful hurricane winds can pick up. Things like cars and homes. And if that wasn't bad enough, you're also dealing with toxic chemicals, power lines, and electricity. Now, one of the biggest differences is the ability to take cover. In wind, you're able to take safety in the most interior, windowless room in your house. With storm surge, there is no safe place to hide in the home. You may think you're protected inside from the water outside, but you're not. Eventually, that high water will be coming in. And depending on the power of the surge, it could rise all the way up to your roof. And that can happen in a matter of seconds. And this is why we always tell you to evacuate before a hurricane.
No worries, Mike made it out all right. But as storm specialist Carl Parker shows us, it's the sledgehammer power of storm surge that poses the greatest threat to life.
When it comes to tropical systems, most people think of the wind first. Even look at the categories. The Saffir-Simpson scale is based on wind. But that's not the true measure of the strength of a storm and the number of fatalities it can cause. Roughly 90% of all deaths from a tropical cyclone are caused by water. These are the results of a study that looked at all Atlantic Basin systems that impacted the U.S. from 1963 to 2012. When you break it down further, storm surge is responsible for 49% of the deaths. Rainfall and flooding, 27%. In all, 1 out of every 5 or 6 Atlantic Basin cyclones caused loss of life. And in the 50 years of the study, about 2,500 people were killed. So heed the warnings from emergency managers when you are asked to evacuate, and have a plan.
Evacuating ahead of a hurricane is often the best plan. Riding out the storm can be dangerous for so many reasons, including the wind. If it's strong enough, senior hurricane specialist Brian Norcross shows us walls and windows don't stand a chance.
In 3.5 hours in August of 1992, Hurricane Andrew did more damage than any natural disaster in U.S. history before it, times almost 4. But a building code revolution came out of it.
Andrew changed the entire way that we build homes. We believe right now we have a very strong code.
3, 2, 1.
The new code called for new testing and a new kind of impact-resistant glass strong enough to hold back a hurricane. For residential windows, that means standing up to a 9-pound 2x4 shot at 34 miles an hour, which simulates the dangerous flying debris that pounds houses and breaks regular windows.
In the large missile debris, it could be items such as garbage cans, lawn furniture, smaller structures or fences, things that may not have been properly secured.
Miami-Dade tested and approved impact windows are roughly 20% more expensive than regular windows with hurricane panel shutters. But they reduce insurance rates and provide important peace of mind.
We do feel very secure that our children can be sleeping in their bedrooms during a hurricane, and we will not have the fear that a large tree branch or tiles from roofs or fencing will come through their bedrooms. The security is worth the price of the windows.
Did you know some damage caused during a hurricane can actually come from a tornado inside the storm? The science behind that weather phenomenon is coming up next. Plus, America's most dangerous hurricane city. Do you know where it is? Well, our experts weigh in the factors that make this place vulnerable to a tropical threat. But first, do you know which hurricane produced the highest storm surge ever recorded? The answer next. Do you know which hurricane produced the highest storm surge ever recorded? It was during Hurricane Katrina at 27.8 feet. That's more than 5 feet higher than number 2 on the list, Camille, at 24.6 feet. It's not Miami, Tampa, New York, or New Orleans. Do you know America's most dangerous hurricane city? Senior hurricane specialist Brian Norcross ran the numbers and weighs the dangers to reveal the answer.
Surging waves and water from Hurricane Ike in 2008 battered the Texas coast just south of Houston and topped the Galveston seawall. A seawall built after the city was destroyed by a much stronger hurricane in 1900 that killed more than any other storm in U.S. history. Although this massive feat of engineering and ingenuity gives the city of Galveston some protection, much more of this metropolitan area has no protection at all, which is why the Houston-Galveston area is number 1 at the top of our list of America's top 5 most dangerous hurricane cities.
Along the coast, anything sitting outside of the current seawall is just waiting to get wiped away by a hurricane. And without a surge protection system, the water is allowed to just freely flow up into one of the most populated cities in this country. That could be catastrophic.
Catastrophic because the Houston metro area has grown about 650% since 1950, with many homes built in areas that will most likely go underwater in a big, strong hurricane.
There are about 6 million people in this region. Conservatively, probably about 1 million people would have to get out of the storm surge way.
Getting out of the way means evacuating on clogged highways through a massive city.
We need everybody to understand if you stay, you run the risk of dying.
In 2005, 2.5 million slogged through the nightmare before Hurricane Rita.
Everybody got on the road at the same time. We have to get people to leave. Well, that decision has to be made early. We're not going to be able to come in and help you once the storm's here.
And another danger is found here in the Houston Ship Canal, the lifeline for the massive petrochemical industry. It connects directly to the Gulf. And when a strong hurricane hits the coast, Gulf water is pushed into Galveston Bay and can surge here miles inland up to 20 feet deep. And worse, the rising surge would be a toxic mix of seawater and chemicals spreading through the industrial and residential areas near the water.
Environmental damage is something we think about all the time. These are not small companies. They've hardened their infrastructure a great deal, but nobody wants to take a direct hit.
Too many people on too few roads, and an especially toxic storm surge situation. Just 2 of the reasons why the Houston-Galveston area is number 1 on our list of America's top 5 most dangerous hurricane cities.
Hurricanes can destroy entire communities, and the damage they cause comes in many forms. Meteorologist Mike Bettis shows us it's possible for a tornado to form inside a hurricane.
Violent winds, epic waves, and blinding rain. A hurricane, it's one of the most powerful forces on the planet, but some pack a double punch, and these monster storms can create destructive tornadoes. The most dangerous was Hurricane Ivan. In 2004, this deadly storm formed 117 devastating twisters. It was the most ever produced by a single hurricane. Hurricanes have many of the ingredients needed to form tornadoes, including thunderstorms, as well as wind shear, which is simply a change in wind speed and direction with height. And lastly, warm, moist air. And certain areas are more prone to this double trouble. The front right quadrant of the hurricane is fertile ground for these tornadoes because that's where we find the strongest winds. So let me show you how this all happens. When a hurricane makes landfall, the friction near the ground slows the winds, while above, the winds remain high. And this creates a rolling motion in the atmosphere. Now remember our other ingredient? It's warm, moist air. And it's buoyant, meaning it wants to rise. And that rising air now tilts our rolling motion vertically, creating a tornado. these tornadoes can be destructive, most producing EF0 to EF2 damage with winds up to 135 miles per hour. But predicting exactly where a tornado will form within a hurricane can be very, very difficult because most tornadoes form within small storm cells that may not appear dangerous on radar. So in addition to all the other threats from a hurricane, tornadoes just one more reason to evacuate when ordered to.
If you've witnessed the damage a hurricane can do, you know why evacuating is so important. Our storm tracker Jim Cantore has endured hurricane-force winds over 80 times in his career, but he's never faced sustained winds like this before.
I'm inside the Virginia Tech wind tunnel where wind speeds can get as high as 190 miles per hour. We're not going to go that high today, but we're going to demonstrate the power of wind by going through tropical storm, category 1, all the way through 5 winds to see how much force actually builds up on me and how much I can actually take. The strongest winds I've ever stood in, probably between 80 and about 95 miles per hour. After that, without a harness like this, there's no way I could stand in the wind. I'm going to be honest with you, I was a little apprehensive at first. I mean, when you start thinking about Cat 5 winds, and then I started envisioning the destruction that they cause, I'm like, I must be on my freaking mind. So here we are now, strong tropical storm force at about 71 miles per hour. We're almost at minimal hurricane. I can feel my skin starting to vibrate. But that was just amazing to me, to watch your skin wave like that. I've never seen anything like it. Here we are at minimal hurricane force. Look what happened. All right, I start going for a ride. All right, here we are at 80. I can't lean into it now. Look at my mouth. See what's happening? No. I mean, this is about the strongest that I've ever stood in at about 90 miles per hour. Wow. We're at 100.
Pretty amazing, right? Well, that was only Category 2 strength. Coming up, the dial goes up to Category 5. Can the Can Man keep his feet on the ground? We'll find out next. But first, what's the highest wind speed ever recorded in North America? And where was it recorded? The answer next. Here's the answer to our last trivia question. The highest wind speed ever recorded in North America was observed on the summit of Mount Washington, New Hampshire on April 12, 1934. A peak gust of 231 miles per hour was reported. That's higher than any measurement ever taken in a hurricane. Wind, waves, and water. Hurricane power is all about energy. Storm specialist Dr. Greg Postel explains exactly how much energy these massive tropical engines can produce.
The force of 500 nuclear bombs. That's how much energy a typical hurricane expends during its life cycle. Hurricanes sweep up warmth and humidity from the warm tropical oceans, and they store this heat in their cores until it's released to the atmosphere through torrential rainfall. Think of a hurricane as one big heat engine, with the ocean acting as its high-octane fuel. The energy released through the rainfall is used to drive the intense rising air within the storm and the strong winds that make the hurricane so fierce. You take away the ocean and the hurricane spins down. Too bad it's difficult to harness this energy, because if we could, it would power the world several times over at any instant.
We promised and we deliver. Weather Channel storm tracker Jim Cantore has seen the worst Mother Nature has to offer, but can it match the man-made power of a Category 5 wind speed in a controlled wind tunnel? Will Cantore keep his feet? Check this out.
So we're going to start off essentially going through a small breeze that you get on an ocean day. All right, so here's 20 miles per hour. People don't realize how strong 20 miles an hour. Your flags are flapping, they're making sounds like that. You get to 30 miles per hour, the water's all chopped up out there.
Here comes the fun.
Holy smoke. Oh my God. It's just deafening. That was crazy. That was just absolutely crazy. The power of the wind, man. It's incredible.
186.
So we got to let's go around 186.9. That's not bad. I don't think I want to go any higher than that. I really felt like I was a piece of dust blowing in the wind. It was a wild ride. I'm glad I did it.
The one and only Jim Cantori. No matter how big the storm, how fast the wind speeds get, or how high the water rises, meteorologist Maria LaRosa says you have to be prepared.
A hurricane is bearing down on your community. Are you ready? If you live in a hurricane-prone area, you'll want to have a hurricane supply kit and a good plan of action. During a hurricane, you may lose power and plumbing. You'll want to have at least 1 gallon of drinking water per person per day for at least 3 days. For a family of 4, that's at least 12 gallons. Buy enough food to get ready for several days. Make sure it's food you actually eat. Other things to have on hand: a battery-powered or hand-crank NOAA weather radio, flashlights, cell phone, chargers, and extra batteries to keep everything running. Keep everyone healthy with a first aid kit, personal sanitation supplies such as moist towelettes and hand sanitizer, as well as a week's supply of any prescription medications you may need. Any important documents in the house, such as insurance policies and bank account records, seal them in a waterproof container before the storm. If you live in an evacuation zone, have your route planned in advance. Know if you're at risk for storm surge flooding and stay safe this hurricane season.
Over the last 35 years, tropical cyclones have caused more damage in the United States than any other weather event. And on average, they destroy more than $16 billion worth of property and infrastructure. So remember, even during a slow season, it only takes one. Thank you so much for watching. I'm meteorologist Alex Wallace.
Wind is howling, the rain is horizontal.
We are in the eye wall of Dennis.